I'm on page 213 in the margin, and this is called the core practice. And I have to confess to you that I really don't get the point of this problem. We'll answer it, but I don't really understand why they wrote it. But here we go. This is called make sense of problems. To make sense of problems, look at all of the given information. Identify what you are asked to find and develop a plan to determine the answer. And before I go any further, I just want to share a tip with you. When I was teaching, my students had an awful time with problem solving. They just didn't know what to do and where to start. So we came up with this little acronym of ROSES. So you spell the word ROSES, and here are the steps. You read the problem, and I know that seems obvious if it's a word problem, but you'd be amazed how many people do not read the problem. They just try to pick out the pieces and solve it without really understanding it. O stands for organize. Find the information that you need to solve the problem and identify the junk, the stuff that you don't need. S is set up and solve. So do the math. And a lot of people stop right there. E is examine or check your work. Make sure you didn't make any mistakes. If there are red flags in your mind, look at those. What is it about the problem that doesn't look right? And then see if it fits. Does it answer the question that you were asked to answer? So that may help you in remembering the steps to problem solving. But in this particular case, we are given a graph on a coordinate plane. It's kind of a funky coordinate plane because the y-axis is kind of in an odd place, but that's okay. This is still 0, the origin. And up here is 2 on the y. Down here is -2 on the y. And down here is -4 on the y. Then we have +2, +4, and +6. And then I have a parabola that crosses here, here, and up here. So we have a parabola that looks something like this. That one's not too bad, is it? If we can get it to fit on our points, and we can't. So let me, I'm going to freehand it, as much as I hate to do that. So it comes up to the maximum, and then it begins its downward curve. So something like that. So the question is, how would you determine if a function has the same x-intercepts as the function shown? Well, the first thing I'm going to do is identify the x-intercepts on here. So this is at 5, 0, and this is at 1, 0. So identify the pieces that you're looking for. This piece has nothing to do with it because we're not looking at that maximum. We're looking at the intercepts. And then you would need to factor your quadratic expression, or let's just say the function, to find its intercepts. And then you could compare the function to this graph and see if the intercepts are the same.